all right? And then the first row, probably you can do it. The second row is much more difficult. It requires static. But that I will explain it to you Tuesday. But you should start doing this, especially we will see this example today requires centroid and moment of inertia. You should review also your centroid and moment of inertia. It's required. So before I go, as usual, start doing an example of the bending. And one question was asked about one of the homework that I gave you, that there was two-gear system there. The idea is just like this. So if you have here an engine running, here is a motor running, and then it comes to a gear system. So, and then that is related. So, and then this become attached to another gear. Notice that eventually this motor is going to create a torque coming to this gear, coming to this gear. Okay, please. All right, and then when you hear, there must be some other attachment to this shaft, which the machine are using those torque. So it become a user shaft. So I said in one of the homework that this, whatever we are creating here, 50% is used here, 50% used there. So that was the question. So let's assume you have 120 here after changing it, you see. You start here, you go through this change, you come here. If this is 120, the question was, so 60 here, 60 there, is that. However, what's the torque here? The torque here is 60. What's the torque here? It's not 60, it's 120, that's exactly. So if you know that, so that was the question that I raised in one of the handout question. The 50% of the torque being used by that 150. We can change it to 40, 60 or whatever. So that is, but these are becoming, whatever you are creating here is going to be used here, and so it becomes.
So if it was 3, then it would be 40, 40, 40? Or?
No, depends how much power you need for each machine. If you have a machine, you need only 2 kilowatts, so use 2 kilowatts. But this is how the torque is going to be used by some using machine, whatever is attached to that system. In this one, we want they need equal 60 and 60, but the torque in the shaft are different. But if you have a machine here which is idle, all of it is available for this one. That's why 0 and 120. That depends how the machine is acting.
So the problem is there.
Yeah, that's part of a problem.
Right.
Yeah, that's part of the data.
That's okay.
No, the question was, since I said 50 and 50, that was the question. How do you divide the 50 by 50? It's obvious, but somehow people think maybe this is a different question. It's not.
Yep.
Yeah.
If the gears were different sizes, would it matter?
No, that changes just changes the shear stress.
Okay.
The static has nothing to do with the size. Remember that, guys? You have to remember that. The static has nothing to do with the size of the shaft. The size of the shaft is only for phi deformation.
Okay.
You see, it doesn't make any difference. This is 10 inches diameter, this is 1 inch diameter. Still here is 60, here is 120. You answered me. That is irrelevant from the size. But if the torque is larger, in order to reduce the stress, you want to make it a little bit larger in diameter as well. So if you are making it all the same size, something is missing there. You follow what I'm saying?
Yeah.
Yeah. If this is all the same size, so here it has 60, here is 120. 120 this tau should be less than limit, so here you have plenty of room there, but you are not using it because it's simpler to make. So many shafts are the same size, but sometimes we change. That depends on the torque, yeah, the amount of torque. Okay, now let's go back again to the idea I presented to you last time about the bending. I give you a bunch of formula. Those are all irrelevant because the formula will be given to you. Can you guys, one of you guys, explain to me what happened in a cross-section of the beam? This is the key. I told you to remember that I used to study, but the unfortunate problem is this. When you have to work on this homework and the quiz, you probably did not have a chance to go through your note and study that part, yes or no? But I hope that at least you remember part of it because I'm going to repeat that. Here, I have here, this is a beam, generally across. I'm showing just the part of it. This is a part of a beam. This is the length of the beam. I'm cutting it out. And I'm putting here this M here. So this M is there, correct or not? And the cross-section could be any cross-section. Today I brought this to show you the cross-section of the beam. You have seen this in the static, yes, or this is, we call it white flange beam, or the type of steel beam like that. They made it for wood as a sample. The length of the beam is like this, going like that. Then here is the moment. Is that correct or not? Now, tell me what happened in that section. I don't care about the formula. I want the ideas there. Those ideas, you can solve problem with it. Without those ideas, you cannot do anything. So what's going to happen here? It's going to be under normal stress, first of all. Yes or no? That's the idea that everybody knows. And how does normal stress change it? Part of a section is going to be under tension. Part of it going to be under compression. So in other words, if the cross-section of that, now I'm showing the side view of that. If this is just for simplicity, this is the way you should study your note. If this is the cross-section of the beam, which is this way, looking that way, yes or no, and subjected to this moment, first thing we have to do, remember, we have to locate the neutral axis, because part of a section is under tension, part of a section is under compression, and the dividing line is neutral axis, and everything is measured from that. So remember that. It's very important. This neutral axis from now on for this chapter, next chapter, next chapter, you start from there. When we show a beam actually like this, and we show it like that, remember many times we show beam like that. What do you think this line is? This line is not the size of the beam. This line represents the neutral surface. Everybody understand? Because we don't care about the rest of it. The rest of it comes in this definition. Now, there is a moment there. This is the centroid, yes or no? This is a phony M, everybody understands. This is internal M, which balances your external. But in actuality, there are stresses there, yes or no? And that stresses goes by this formula. See, this is the one you should remember. Epsilon was equal to minus y over rho. Rho is constant. Epsilon is the strain. So a strain in the cross-section. This, are you with me? Please put that aside. That's exactly what this is exactly what you are going. Not even you are not understanding whatever going on with this. You are not missing the entire chapter. Without this, you cannot go to do any of this problem. This is what the gentleman back was trying to do, and you are doing right in front of my eyes. At least hide it from me. Sorry, because then. You are not supposed to do that. That's really, you are paying at ease. If you listen and understand it, you can do those homework. The formula does not help you at all. Now, going back again, one more time. This is the neutral axis, yes or no? When we're going up, because everything changes by y, yes or no? So therefore, you are here. This distance is y, and everything is measured from y, and y is 0 on the neutral axis. The stress is 0. As we going up, it changes linearly, first of all, because it is changes with y. And then this way, because y is constant, the stress is constant. So horizontally in the section, in the cross section, if you have a section like that, like this, again, this is the centroid, yes or no? Here, stresses are constant, but as we going up, the stress keep changing in this format. Yes, this format and that format, because one is in tension, one part is in tension, depend on the direction of the moment. Notice, I can use the moment this way, or I can reverse it. Everybody understand that? We have this moment, or we have that moment. Is that correct or not? Therefore, this moment, as I said, is not a real moment. This is internal. Internally, what's going to happen in this cross-section, we are going to have here, in this case, having compression there, 0 here. So there are forces going in which represent the compression there. So I'm going to show the tension in color so that way you can see the difference. And this is the tension according to the mode. Notice, this create a couple. Everybody see that? Every two forces here equal and opposite create. That's why we show it like M. Every time we don't want to show it like that. This is the reality. Is that correct or not? Yes? But look, the format is look at this force and this force. That is a couple. You add all these couple together, that become your internal M. The stresses are in the form of a couple. Yes or no? Forces going in, forces coming out. One case. linear. 2, horizontally they are the same, like a prism there. So you can put the here like that. They are coming in, out, and going like that. Everybody see that? You can show it 3D. Is that correct? I cannot show that, but that's what you see it there. Correct? So that's it. Now you change the direction of the moment, so we need what? We need the neutral axis, then the formula. What formula we end up? I multiplied that by E, etc., to get to the formula. The formula was this. This was sigma max in compression. This was sigma max in tension, and in between sigma are different. This is sigma in general, and I gave you the formula. Sigma max was equal to, you don't have to remember this. Again, everybody will remember it eventually because these are the basic equations. Sigma max, it is in your handout, was equal to plus minus MC over I. What are the C? The C's are this C or this C. One of them is for tension, one of them is for compression. They could be equal, they could be different, depend where the centroid is, because if the section is not symmetrical, then the centroid kept upper or lower than the middle, so you have different C. Is that understood? Which we are going to do example there. So therefore, this is rectangular cross section, so this part and this part are equal. Everybody understand that? So this is C. Well, sometimes some book they call it C1 and C2, but here we just call it C in general. Yes? So that was the idea that I presented to you. And for any other point, obviously, I have to change the C into Y. Everybody understand that? Yes? So the general formula, sigma, become, actually, there is the minus there, but don't worry about it. You can decide on plus or minus later on. Minus M Y over I. So when Y equal to 0, sigma is 0, and then Y become equal to C. You just put it there. Right? They put this M as a positive M. If the M become negative, so they put it negative times negative. But generally, I just look at the direction of the moment and decide which side is tension, which side is compression. And on the tension, don't do what the way you did your last quiz. Oh, I didn't give you back your quiz, did I? No, okay, so let's do that at the end. So therefore, because I'm so anxious to get to this lecture, well, I'll give it to you and discuss it there. Because many of you forgot about tension and compression. The rod was in compression. Here you have to be specific. So it is either tension or compression. You decide on that. Now, let's not, while we are at it, let's do our first example. I give you your quiz afterwards. Is that understood? Yes? So this is the example which is in the handout, but I cannot do the first part of it. So I'm going to do the second part of it. So which is the following. We have a cross section like this. This is the cross section of the beam, just happened to be a T section. You see, cross section could be anything there. So, and then it is, of course, symmetrical with respect to Y axis. This is 180 millimeter, this length. This height is 60 millimeter. This height from here to here is 120 millimeter, 60 millimeter. I don't need that. And this length from here to here is 90 millimeter. And the beam itself, this is the example I'm doing, that in the side, if you look at its side view, so this is what you see. So I'm cutting the beam like this. So you see this line here, because this line is this line. And let's this time change it to this moment. This moment, instead of being positive moment statically, it is statically is a negative moment, which means what? Means the tension is on the top, compression is on the bottom, so that's obvious. So that changes from problem to problem. And this M is given 60 kilonewton meter, and we want to calculate the highest value of tension or compression in this beam. Yes.
That's the side view.
Yeah, that's right. This is the cross section. So generally we don't show that, but this goes like that. You see, that's like this. This is the cross section, but instead of being, let's assume it's like that. Yes? This part is not there. The length is here. We don't show the length. But when you look at it like that, this is what you see. Yes? This is side view. That's right. The side view, because the beam goes now, we don't show the length of, we don't care about the length of beam. Not yet, until next chapter. Next chapter, the length comes into the picture, because we want to draw the shear and moment diagram. To find the value of the shear, that's something else. Here we are only subjecting it to a positive moment or a negative moment statically, the cross section is important. Is that correct? This is important just to show you us where is the tension, where is the, by the way, it's here too. Remember that? Here goes like that or goes like this. Is that understood? But it's hard to show it here. Yes? Correct? So what should I do now? In order to find the stresses, what should I do? First, locate the neutral axis. That was part of a lecture. So I need to find wherever the C is. In order to find the C, I need to choose an axis. You can choose it on the bottom or on top or anywhere you want to. That's from a static. Then you calculate this y bar. I do not need x bar because with respect to the y-axis, it is symmetrical. Yes or no? Correct? So that's not your job. I'm going to do it. I'm going to put number down. If you have any problem, that's you have to go back to your static. You should supposed to study it last weekend, but because of this you didn't, but at least you have this weekend to do it. Is that correct or not? Two things you need to know. Centroid and moment of inertia, it come to every problem in this chapter and next chapter and next chapter. Moment of inertia and the Q. You need the Q, we knew the moment of inertia. We already used the polar moment of inertia in the previous chapter. And parallel axis theorem. You need to learn it. However, if you already know it, good for you. If not, you need to review it. Anyhow, y bar, in order to calculate the y bar, I do not need the table. I divide that into two areas, the upper area and the lower area. We can color it or we can do it differently, however you want to do it, just to show how that works. This one and the lower one, we shall just do it this way. So area 1 and area 2, and in the numerator are the Q's. Denominator are the area. That's all you have to know. In the numerator, when you multiply A by I, those are the Q. Everybody understand that? I defined the Q for you. What's the Q of this area with respect to this neutral axis? You have to take this mass. This mass is 90 times 120. The area represents the mass. So this area represents the mass of that one. Where is the center of that? The center of it is there. Yes or no? Correct? And you are taking moment of that mass about the x. In effect, that's what you are doing. That we call it moment of area. Area doesn't have a mass, but that's in effect we are doing. Is that correct or not? So what's the distance I need? The distance, I don't need this C. I need this C1. The C1 is at the middle. This is 60. So this is 60 and 60. That's 120. So I multiplied by 120. Yes or no? Correct? Area times A. Area times A. Is that correct or not? Yes? Area times Y. I'm sorry. Area times, this is the area. Yes? That's the time Y. Is that correct or not? Yes? In your table. Plus, as I said, I don't want to teach that. Plus this one. This one is 180 times 60, which is the area. Where is the mass center? The mass center is at the middle of it, multiplied by 30. That's right. So that's 30. Those are your Q's, Q1 and Q2. Remember that for next chapter as well. Divided by area, which are the representation of the masses. We don't need that, or we should just leave it there. This is C2 and this is C1. And then the 90 times 120 plus 180 and 6 times 60. So those are two areas. These are the two Q's. And because you have two, we don't need a table. If it was 4, 5, 6 section, we use the table. Generally, we don't. It comes to 75 millimeter. That means the Y bar here, I take it out and put 75 millimeter here. It means it is 15 millimeter above that where the two meet together, is two surfaces. Correct? Yes? All right. So now we have this distance. This is now just to make sure that you are not making any mistake. Actually, now if this is my neutral axis, notice this is C1 and that is C2. Is that understand? The furthest distance from the neutral axis defines C's. Is that correct or not? Because it's not symmetrical. That section was symmetrical. That section is not symmetrical. Is that correct or not? Yes? That's what you need. 105 and 75. Correct? So that answer. The next, of course, is moment of inertia, not moment of inertia with respect to this x-axis. When what we were doing there in the static, I probably have mentioned that in my classes, and you have heard it from your instructor, that the moment of inertia that you actually need is the moment of inertia with respect to the axis that passes through the Now you know why, because centroid is the key for entire problems, is where the stress is zero. Stresses start from that point. So from now on, remember, make a note that every problem starts from centroid, either up and down. As I said it earlier, this is the neutral surface. No, this way is surface, that way is the axis. Correct? We don't show even the height of the beam here. We always show it like that because we don't care. We just this one, and here is the neutral surface. Everybody see that? That where the C is. Anyhow, that's understood. Now I'm going to erase that because now we know where the tension and where the compression is. Is that correct or not? Now, calculating the I, that is also your job. I with respect to neutral axis or whatever you call it. Here I call it X, I can call it X2. Is that correct? Or just most cases it's the Z direction, doesn't matter. So we need the I of these two areas again with respect to neutral axis, which require parallel axis theorem. So let's do the lower part first because it is simpler. This one, area 2, it is 112 of base. Base is 180 times height. Height is 60 to the power of 3. Everybody should remember that one. 112 of base times height to the power of 3. That's one number I ask everybody to remember. I keep saying don't remember any formula, but this you are going to use it so often in the next 2-3 chapters. Everybody eventually will remember it. Is that understood? 112 of base time, height cubic, plus what? Plus, because this requires, what I just did, calculate the moment of inertia with respect to this x prime axis, yes or no? Then I need parallel axis theorem between this x and this x. Now this is neutral axis. This is the one I've got. These two, there is a distance here, yes or no? So plus area times distance is square. Area is 180 by 60 times distance is square. This distance between the two here is 15 and here is 30, so it is 45 to the power of, some people forget about it, AD square. Yes? This is, you want to study I with respect to x equal to I with respect to x prime plus AD squared. This is the one that passes through the centroid. Is that correct? Yes? That's parallel axis theorem. Anyhow. And then we do the same thing for the upper part. So plus 112, the base of the upper part is 90. The height of it is 120. You don't have to divide that into two parts. You can consider it as one section altogether. It's easier. To the power of 3 plus the area, 90 times 120. Again, when I did that, I calculated with respect to this x prime. Is that correct or not? Yes, because passes through its center. Then I have to, there is a difference between the two. I need this distance now. This distance is 105, so this is 60, so this is 45. Everybody, again, happened to be 45, just for simplicity. 45, because this question was a quiz question, so I made it a little bit simpler. Is that understood? Yes? So therefore, you calculate your I. Your I ends up to be equal to 59.95 times 10 to the power of 6 millimeter to the power of 4. Now, in your quiz, which I'm going to give it back to you in a minute, there were many mistakes for this reason. One, concept misunderstood. Second, the unit is all wrong. Third, there are no plus or minuses. Tension is plus, compression is minus. And as you see here, part of a section is in tension, part of it is in compression. All of that has to be recognized, and the most importantly is the unit. Look, many mistakes in the unit, which throws the whole system out. No, this is in millimeter square. The stress is in Pascal. Pascal in metric system is Newton per meter square. So I have to either calculate that in the meter square, which you do this. You put 0.18 here, 0.060, which is correct, but it is you do lots of mistakes because of those all zeros. Everybody understand that. I rather you to use the number given, come to this one. Now here it is millimeter to the power of 4, and you want to convert it into meter to the power. What should I do? I should divide that by 10 to the power of, not 3, 10 to the power of, not 4, 10 to the power of 3 to the power of 4, which is 10 to the power of 12. This is the simplest method I can suggest to you. So look, if I divide that Divide, because each millimeter is 1/1000 of meter, yes or no? But since it is millimeter to the power of 4, you don't divide it by only 1000. You divide it by 1000 to the power of 4, which is 10 to the power. All you have to do, change this +6 to -6, you are done. Look how simple this is. So if I change that to 59.95 times 10 to the power of -6, we have converted from millimeter to millimeter. Please use this one, okay? What did I ask you to use for the epsilon? I asked you to use micro, yes? How many of you did in your quiz you used it? Maybe 2 or 3? Back, so output this, and then you make mistake. You don't get the idea there. If you express it in macro, you are making no error there, because it comes to 5,000, 200, 300, or 2,000. Everybody, rather than 0.000, sometimes you put 10 to the power of -4, sometimes you put -5. These are all, how can you add those numbers together? Everybody understand that when you want to add it together, it's difficult. Is that correct or not? Yes? Anyhow, actually, I'm going to round it off because for simplicity, this is 60 times 10, because we are going 3 digits. 10 to the power of -6, meter to the power. Go from +6, you don't have to do that. Go to -6, your conversion is done. If you keep it in that format. I hope you do that for metric system from now on. Is that understood? Yes? Okay, now we are done. So the static part of it, the rest is very simple. What's the sigma max now? Where is the sigma max? As far as tension is goes, I erase it here. The tension will be what? Because I have to show you one more time. I should not have it. So this is now the section, and this was the moment. Is that correct or not? So the tension is on the top. So sigma max in tension is equal to plus M. M is 60 kilonewton meter. So I need to turn it into newton. So that is 60. I put the unit for the first time. Then you can avoid that afterward, but you have to be able always to check it. 60 newton multiplied by what? MC. Remember, that formula is exactly like your previous formula. There you had tau equal to Tc over J. Here you have sigma equal to MC over I, the same format. Yes or no? What's C? What is the C now? The C is 105 millimeter, but I have to convert it into meter, so it is 105 meter divided by moment of inertia, which is 60 times 10 to the power of -6 meter to 1. Now check the unit. 1 m here, 1 m here become meter square, and this meter square drops out. Please pay attention. I explain it to you. So again, and the unit is Newton per meter square, which is Pascal. So the answer is in Pascal. Yes or no? Not KSI, PSI. Those are our system. Pascal, kilo. We always express it in Pascal. Pascal is a small unit. We generally do it in kilopascal or megapascal. For a steel, this is a steel beam. We are going to go megapascal. Megapascal is 10 to the power of 6. Don't look what happened. Keep this out of your calculation. If you do this, this is the number for megapascal. Everybody see that? There is a 10 to the power of -6 which goes to the. These are all designed this way in order for you not to make any mistake if you follow this procedure, not the way you do it, or you are coming all with. I'll show you when you get your quiz. I'll do it and you do it and see the difference. Is that understood? Now here, so this number, actually this 60 and 60 drops out. This time that becomes 105. So it becomes 105 times, this goes to the numerator, 10 to the power of 6 Pascal, or equal to 105 megapascal. If you go to the table, you will see that the yield strength for a steel, you remember the yield strength, sigma yield for a straight, is given 250, not Pascal, 250 megapascal. So we have a factor of safety of almost 2.5. If the sigma yield was 250 for this steel, we still have 2.5 factor of safety, almost. Is that correct or not? Yes? So that's what the relationship. Of course, we have to calculate sigma max in compression, and that is minus. So remember that minus. So again, the same thing. Now, since this is linear, sometimes in the solution manual, they use the ratio. Everybody understand that? Because if this 105 becomes 70, the stress is 75 over 105. Is that understood? The reason is the stress was linear, so you can use the relationship. Is that correct? However, many people do not pay attention that. They use it one more time. So let's use it one more time. 60 times 10 to the power of 3 multiplied by 0.075 divided by 60 times 10. Notice everything is the same except these two, so that means I can use the ratio. Is that correct or not? And remember, look, it's linear. So if you go here twice the distance, here if you are half the distance, the stress is half of that. Is that correct or not? All because of this equation. All because of that. Yes? So that's it. So this becomes equal to minus 75 megapascal. So instead of that, this is what I'm saying that. I could use this. I hope you understand the math part of it. Minus is minus. Then I say I had here 105. So I say 105 multiplied by 75 over 105. That's the ratio I have. Is that correct or not? Yes? Either meter or millimeter doesn't make any difference. Is that correct? That's the same answer. So therefore, it becomes minus 75. So you don't need to do that. So that is the maximum. Now, can you calculate the stress at this point? Because that's some of the questions are like, is that the stress at that point? You cannot use this equation. You have to use y. Is that understood? That all you have to change the c to the y, correct? But you have to be careful. Are we in the tension zone or are we in the compression zone? We are on the compression zone. Everybody understand that? So therefore, you have to calculate that. And one more time, this is what we are talking about. If you want to plot that, that one end up to be 105. Centroid is here, so that's a 0. These are in tension. This is the stresses we came out like that. And here the stresses went here to the maximum compression of 75 megapascal in megapascal. Of course, if I ask you what's the stress here, the y at that point is only equal to 15 millimeters, as everybody sees that. Correct? Yes.
Where's the M coming from? The newton meters? 60,000 newton meters?
No, I gave it to you. Oh, I'm sorry. Oh, I raised it so many times, you know. The moment was like that, and the value of that was 60 kilonewton meter. One more time. I erased it because I showed you in this format. The cross-section was subjected to 60 kilonewton meter of moment. I'm sorry, I put it there at the beginning, but I erased it.
And for the 15, you do the height of 15 where it turns to C. Can you still do the ratio for that too?
Yeah, it is linear. The stress is linear. For any point, you can use the ratio. As long as linear. Chapter 6 is not linear. Remember that. This is only for this part of it, not all. Because of that, again, remember that epsilon. And remember, if I multiply that by modulus of elasticity, this becomes sigma. Sigma is also related to y. That was the whole idea presented to you. The rest of it, you can forget all those formula I gave you. The idea is this. Where is the neutral axis? How the stress keep changing from neutral axis to above and below, and what is the horizontal, vertical versus the vertical. That's the whole idea. Yes? Everything starts from neutral, remember, for this part of it. You see, this part of it becomes a little bit complex for a student because they forget about this part. Everything, you have to turn everything from the centroid and go up or down. Is that understood? That up and down is part of characteristic of stress distribution due to the sigma, due to the bending. For the torsion, it was different. The torsion center was 0. Everything was circular. Remember there? Then we went outside, which reminds me to give you some other idea too. Now, before we go any further, I want to give you your quiz back. I'm sorry because I was so excited to go into the because we are quite frankly behind. So this is your homework by the. Please pay attention. In this problem, some of you, of course, many people got 15 and above. Several people got 20, but several people had a little bit difficulty from the problem and understanding the idea behind the generalized Hooke's law, which is either one-dimensional or two-dimensional or three-dimensional. As a matter of fact, part A of this problem, there is nothing there except a simple material under pure compression, which is lecture 1, first class. Every item under compression doesn't have. We started with this, guys. We started with a rod like this. A rod or cubic doesn't make any difference under this. This is lecture 1. Is that correct or not? What's the difference between this and that? Nothing, except the shape of it is a little bit different. Is that correct or not? So there is a vertical load. I said it there. There is a vertical load there. Some people, for this problem, calculate sigma x and sigma z. I have no clue where the sigma x and sigma z coming from. The stress is only in the direction of sigma y, and you need this cross section. Yes or no? Is that lecture 1? Is that correct or not? Everybody sees that, should see that. Why you are making a mistake with this is it. Force over area, and it is in compressive format, therefore requires a minus. It means it's going to get shorter, not longer. Is that correct or not? Then I need to calculate delta. Now, you can calculate delta there, but there is delta is not required. I asked you to, because the subject, the idea of this chapter was epsilon. Is that correct or not? Epsilon and modulus of elasticity. So instead of using delta, which is much longer, all I asked you to calculate is epsilon x. Is that correct? Or in this case, epsilon y, because the force is in the y direction. Yes or no? So epsilon y equal to what? Equal to sigma y divided by modulus of elasticity. So therefore, all was given. That's minus 500 psi. Of course, you have to use a psi. So if this is psi, the E has to be in psi, not in ksi. I give you 400 ksi. So 400 times 10 to the power of 3 psi. Is that correct or not? So therefore, the answer is negative. So it becomes 1,250 micro. What's the micro? Micro is 10 to the power of minus 6. I asked you to do it this way. Not many people did that. A few people did, which they put them in the much faster track. Everybody under by putting 0.000 there, that turns you into a more error, more timing, etc., etc. That I said unit. But as I said, they are not using a solution manual. Do not blame you. But I ask you, please do it this way. Is that correct or not? Yes. Anyhow, putting it this way is also correct. Minus 0.001250. Is that correct? That's the answer, either way. And then, of course, I asked you to calculate the length, the change in the, notice there is no sigma x, there is no sigma z. Is that understood there? So there is one dimensional, so that was a throw-in. That was your first few homework, last homework was like this. Homework number 1 and 2 was this problem. Why you missed it, I have no clue. Anyhow. So delta y, so actually, or delta on that direction, which was 6 inch if you want to calculate that one. So therefore, I did not calculate. Actually, I didn't ask for your class, by the way. This was for the other class. For your class, I did not ask any of them. For your class, read the question. I asked you, many people calculate the change in the height, length, and width. I didn't ask that. All I asked is the change in the length, yes or no. What is the length? Well, this is the length, actually, is the 8 inch. Is that correct or not? Yes? So the 8 inch, so I want to calculate epsilon z now. Now, epsilon z is equal to minus nu epsilon y by definition. Is that correct or not? Yes? Correct? Because it's one dimensional. I don't have anything else there to worry about this. So that's the definition of the nu. So you calculate that one. It becomes minus 0.4 times minus 1,250. So it becomes equal to, I believe, what was the epsilon on the other side? So I have it 500. So it becomes plus 500. So it is minus and minus. So it means when you push it this way, this side becomes larger. Is that correct? And this side becomes larger. Nevertheless, the delta in the length, which is the 8 inch, becomes 500 macro times 10 to the power of minus 6 multiplied by 8 inch. So that becomes 0.004 inch. Then I asked you to calculate the change in the volume. I said it in class. You have to recognize that these deltas are very small. You don't add it to original delta. I said you have to calculate the E. E was the amount of change for 1 cubic inch. Is that correct or not? In order to calculate the E, I need epsilon x, epsilon y, and epsilon z. But since this is the same way, because epsilon z also equal to epsilon y equal to y, because epsilon z is also equal to minus nu sigma epsilon y, epsilon y. So that is also equal to 500. So you have 500, but these are epsilon. Now, some people even mistaken epsilon by the delta. I asked you to calculate the change. I did not ask you. Epsilon is the amount of deformation per unit of length. So you have to go, if you want to change the delta. Notice what I did here, and many people do it, of course, correctly. Now, the next question is this. This is question A. The question B was the change. No, it still is volume. Still we are question A. The volume, I need E is equal to epsilon x plus epsilon y plus epsilon z. It was in your handout. It was in your some of the examples. So therefore, that is 500 plus 500 minus 1,250, all in macro. And then these are all in macro, so it becomes minus 250 micro. That's right, minus 250 micro. So eventually it's going to get a little bit smaller. It's obvious. It's under compression. Yes or no? Is that correct or not? There you say, okay, delta change in the volume equal to minus 250 micro, which is 10 to the power, times original volume. What's the original volume? Original volume is 8 by 6 by 4. So you just calculate that one, and the answer will become equal to minus 0.048 inch to the power of 3. Some of you try to add length to that. I said, no, we are not going to do that. That's the wrong method. I give you partial credit, not the full credit, but that's not.
Length always on the z-axis?
Length is the one is longer, usually. Okay. Not the axis, no. No, that's right. The length is the largest, by the definition of the length of the height and the width, yes. Okay. Yes. Okay, if you make that mistake, let me know. Is that good? But that's it, okay? All right, because it was not 100% clear, but the length was, in this case, it happened to be in the z direction, because the 8 inch happened to be in the z direction. That's the length, that's the largest dimension. I said it's not in the scale in class, so okay. Then this was case 1. Then what happened in case B, in the change in the length of the block when it is held inside a rigid grip, like now. When it's holding this block now, this side, see, when it is inside the block, this side and this, right now, as you see, there is an epsilon x there. Is that correct or not? Yes? We calculate epsilon, we needed epsilon x here, sorry. That was epsilon z, and this is epsilon x. Is that correct or not? So there is an epsilon x there, because it's free to move. It's going to move this way, yes? But if it was in a rigid place, then it could not move, yes or no? If it cannot move, then it creates a sigma in the x direction, yes or no? Because holding it in that direction. Therefore, all you have to do, which again, I explained it in class, it was part of your homework. Some couple of your homework were like that. There are, at least I remember 2 or 3 of your homework had this idea in it. So therefore, epsilon in the x direction must be equal to 0, correct or not? Yes? So you are not letting it move in the x direction. Look at the picture there, correct? And therefore, you have to put epsilon x equal to 0. Epsilon x was equal to sigma x over E minus nu sigma y over E. Of course, there is minus nu sigma z over E, but that direction is free to move. Therefore, sigma z must be equal to 0, correct? So since this is equal to 0, you don't need the value of E. It drops out. So sigma x become equal to minus nu sigma y, or become plus. Minus goes to the other side, become plus. Obviously, the answer should be in compression, because it was to expand and you are not letting it. You had this problem many times. In temperature, you had that one. Notice in the x direction, as soon as you push it, this is all logic, guys. The only problem I guess you have, you are not thinking logically about this action. And engineering is all about that. If you want to become a good engineer, you don't care about sigma equal to P over A and this and that. You want to think about the logic of this problem. Wouldn't you, when you push it this way, this side wants to go out this way, and you are not letting it out, obviously it is in compression. So if you don't get it negative, there is something wrong with that. Is that correct? But it can become plus 0.4 times what? Sigma y. But sigma y was negative. Is that correct or not? Yes. So minus 500 psi. So it becomes minus 200 psi. Now the scenario is this. We have sigma x minus 200. And we have sigma y, how much? Minus 500. We don't have any sigma z because z is free. Actually, that's the question you want to answer. Is that correct or not? The z is free. So this is the question you want to answer. Sigma x equal to minus 200 psi. Sigma y equal to minus 500 psi. You're summarizing it, which you don't need to do it in the quiz, but that's what I'm referring for future system. Yes or no? Correct? So does it change the z direction? Of course it changed the z direction, because z direction previously, look what happened. The z, when you put pushing it down, this one is going to increase, yes or no? Now you are pushing it this way, that side should be a little bit more increase, so you should get 2 positive, correct? Yes? Are you with me or you are not listening? Did you? These are all logic. I'm pushing it, when this wasn't there, I'm pushing it this side goes this way, yes or no? Become larger. Now that I'm pushing it this way, this side should get a little bit more than before. Is that correct or not? And that reflects into your equation. So epsilon z equal to minus nu sigma x over e minus nu sigma y over e. But it looks like minus minus, but sigma x and sigma y both are negative. Negative times negative become positive. So this is what you get. You get minus, these are all logical, sigma x minus 200 over e. You have the value of e given there. Minus 0.4 minus 500 over e. So it become, you put the e there, so epsilon become, many people did this correctly. Actually, epsilon become plus and plus, so it becomes 700 micro, which is, as you see it, before it was 500. Everybody understands. Before it was 500 when it was alone. Now it is 2 actions, so it is 500. It's all logical. And then you calculate delta, again, L, which is, or delta Z, whatever you want to call it. This is 700 micro times 10 to the power, multiplied by 8 inch, which is the length again. So it is 0.0056. The last part I just throw in to give you extra point again, but many people didn't do that part. I don't understand that part because 3 of your homework were exactly like that. It's so simple. I don't know, because that's the basic of this. You are holding it between 2 this way, and this wants to slide up and down, because I said the bottom is not hitting anywhere. That's purpose here, assuming this is not hitting anything. So this is your force F, and F equal to 16K, yes or no? Is that correct or not? And this wants to go back and down. I believe I give you 2 homework like that. Is that correct or not? Where are the shear forces? The shear forces are here and here. Is that correct? This block of rubber between a hole like this. This is so obvious. Push it down, please. Push it down, yes or no? Where are the shear forces? This is basic idea of shear. There's nothing there to worry about. This is again in chapter 1. Is that correct or not? But the shear is here and there. So many people who understood it asked us, so this is the shear force on one side, this is the shear force on the other side, because double shear you call it, or therefore each force in each surface, you can call it 2 surface, or 16 divided by 2 surface, or 8 divided by 1 surface. Is that correct? Because this is 8, correct? And this is 8K. Yes? 2 sides of it, rubbing against the metal. This side, and that side, the size of it is there. So it's a block of, look at the size of it. That's 8 inch by 6 inch. Is that correct or not? The side, correct? Understanding the idea, then you can do it. Tau equal, that's all I'm asking you. 8 divided by the 8 kips divided by the area side of that block. Side of that block is 8 by 6. That's right, 32. Yeah, so it becomes 167 psi. One liner. Just basic idea of a static. Anyhow, so that was that one. Now, how much time do we have before the quiz? So 5 minutes? Okay. Now, notice there is 5, 6 problems there. All of them are this in nature. The way I did it is that you are calculating maximum sigma. However, there is one more item in this next 5 minutes, which I'm going to explain it to you in order for you to do your first line of homework, plus the centroid, plus moment of, if you have problem with that. The next question is very important. Please pay attention. It all comes from that equation. Now that I explained this equation to you, you would appreciate what will going to happen here. We call it composite beam. So please write it down. Composite beam action. What will happen if I have here a cross section of the beam like this? And let's say this part of it is wood. And suddenly, I will explain that to you. On the top of it, I am putting a plate of, let's say this is the same thing like that. Look at it. This is a cross section. This is wood, this is wood, this is wood. Suddenly, I take this out and put a steel there. Is that correct or not? This part of it is different material. So let's put it this way. Let's assume that, of course, everybody knows that the steel is, again, this is the cross section. Everybody understand what I'm saying, that the length of it doesn't matter. We all talk about in this chapter, next chapter, we are talking about cross section of the beam, but it's the one material, is two material. Where is the centroid? If I give you, let's put some number then in order for you to understand that. Let's say this is equal to 6-inch width, and let's say this is equal to 8-inch height, and this is 2-inch height for the total of 10-inch. If this was all wood, the centroid would be at the 5-inch. Yes or no? Adam, is that true now? Is it the centroid at 5-inch? Because metal is much heavier than, so therefore, none of those formula that I used previously in a static, which are y bar and the I, is not going to work, isn't it? Because every time we were using that equation, you probably remembering my sentence or your instructor. We said every time we use that y bar and that I, we said the material, all the material should be from the same, all the parts should be from the same material, the same thickness. Remember that idea? Yes? Now it's two different material. Steel usually is much stronger than the wood. So let's assume, this is just for the sake of the discussion. Let's assume that E of the steel over E of the wood is given equal to 10. This is just for example here. We usually call it that N in general discussion. So N is larger than 1 because the steel is stronger than wood. Now what happened here, we have to go back to what I just told you a minute ago and in the previous class and see what's going to happen here. Again, I'm going to show you the length of the beam. This is the length of the beam this way. This is, again, beam. This is the side view, as you said it. This is the cross section. Yes or no? So when you look at this side, that's what you see. This part is wood. This part is steel. So let's assume the centroid is here somewhere. We don't know where it is, but let's assume the centroid is there. Yes or no? Correct? If I want to draw my strain in this cross section, remember the strain was equal to minus y over rho. Yes or no? Correct? The strain has nothing to do with the modulus of elasticity. The strain only related to the y. Yes or no? When you go higher, the strain gets larger. When you go lower, the strain gets again larger in positive or in negative format. Yes or no? So if I draw my strain here, this is 0. This is minus epsilon on the top, and this is epsilon according to the y changes. Is that correct? I'm assuming this length is larger than that length. Is that correct or not? Yes? Correct? Now, what will happen if I want to draw now the stress for this one? All I have to do, multiply this by modulus of elasticity. Look, this you know what that is. If you use it correctly, E times epsilon is what? E times epsilon is sigma. Yes or no? Remember? This was the idea I presented to you in your quiz. Epsilon was equal to sigma over modulus of elasticity, or sigma equal to what? E times epsilon. So in other words, if I take this epsilon multiplied by E of the wood, remember, this is the wood area, and this is the steel area. Is that correct or not? For this part, from here to here, I have to multiply epsilon by the value of E, which is a constant. Yes or no? So I get my sigma. My sigma now is like this. I show the sigma in red. So I get my sigma here, which is much larger. This is not the same scale. This is my sigma here because I take the epsilon multiplied by E, and I go to this point is 0. This point end up there. I end up here. Yes or no? As soon as I pass the wood, I have to go to still. I don't have to multiply it by E of still, not E of the wood, which is 10 times larger. Therefore, suddenly I have to take this epsilon multiplied by E of the wood, but that epsilon has to be multiplied by E of still. So therefore, this goes 10 times larger and then goes like that. So as you see, these are the stresses. And the stresses in the steel is much larger than, of course, that's the idea. If you have two persons holding something, one is the stronger, one is weaker, one is older like me, the one that's stronger will carry more load. Is that correct or not? Yes? So what should I do there? I should change this steel into wood. Yes or no? If I do that, notice if the ratio is 1 to 10, I can assume that 10 square inch of the wood is equal to 1 square inch of the steel. So all I have to do, take this steel and expand it 10 times in area. Yes or no? However, I cannot change the y, because if I change that, the whole epsilon, everything changes. I have to change it horizontally. So let's write it. Change the area into n times, or this time n, 10 times. But it changes only horizontally because you do not want to change the height of the beam. Is that correct? That cannot change. So this become eventually, I just leave it at that, and next time I do the example. So in other words, you keep the wood stays there like that, 8 inch by 6 inch. Is that correct or not? You cannot change the height. The height is still, this is 2 inches, but suddenly that width, if the ratio was 1 to 10, this 6 inches of a steel becomes suddenly 60 inches of a steel. Everybody see what happened? So that become, of course, both sides should be symmetrical. So you change that. This become 6 inch times n. In this example, becomes 60 inches. They are all wood. As you see, it become a T section. Then you can find a centroid. You can find a moment of inertia. Of course, somebody in the other class said, can I keep the steel and shrink the wood into a steel? Yes, you can put a little bit of steel inside. Steel is a T section, everybody. You can change it to all wood, or you can change it to all steel, and then the problem becomes exactly the same as before. I'll do an example. I'll show you how that works. It's very simple. So by doing that, you should be able to do first line of all your example. Put everything aside. We are going to quiz now.